Hi, welcome to Amberskies. Yes, I'm Blades, I'm back, and we are loading up a programming environment. Yes, we're back programming today. My brain is on holiday, which is perfect for programming, so brain's off planet. I'm high on painkillers, and I'm here to do some fun programming. Now, if I remember rightly, I'd just forced, on the last stream, I'd actually forced our test program to take colours or textures as an input. And there's big reasons behind it. You were right there, Muppet. This on your neck. What the heck's that? It's a wiki. You had a wiki on your neck. Right, yeah, here we are. Got it. We've got the environment. Let's see what we're doing. Let's get on with it. I've got to move a bit faster today because we need to get quite a lot done. We should be doing a default. Oh, that's me messing around with DTLS. Okay, we don't need that, do we? No, we don't. Let's close that. Close the workspace. Do you want to save your workspace configuration as a file? No, not really. Open folder, add workspace. No. Let's see what we're doing. Amberdev, workspace. Here we go. Right, here we are. So I just finished off, and I think I finished off with highlighting these and saying something like, why don't we just read a file full of these? And then I looked at it and realised there weren't any doobies. What are they called? 90 degrees to the face. Normals. That was it. There's no normals. So we do have to add normals to this list. Okay, let's leave a note. Hello, pudding. There we go, need to add normals. Yeah, that'll do. Yeah, my screen's all wrong. So, let's set up the screen as well. Sign into chat. Don't know why I have to do that. I do. Doop doop. And here we are, say something. Welcome to my brain off planet. Oh, that didn't work because that all went in here. Not so clever. Alright, let's try a different keyboard then. We close this. Don't know why I need that open. I need it open to chat. Okay, fine. Welcome to my brain on holiday. No, off planet. I think. Ah, that worked. Good. Right. Let's see where you can see that on screen. There, you can see that on screen. Okay. Let's see if we can pick this up and move it properly over. Let's say to here. And that works quite well. There we go. Coffee. So really, that's the file that we need to load. And that file is just going to have indices, positions, colors, textures, and normals. Okay. Let's one unsaved. Save it then. Oh, I don't have autosave on here, do I? Okay. There is an autosave feature on this. Okay. Fine. Add folder to Workspace. Bing. It's tools. What we're going to do is we are actually going to create a tool for it. Put VS Code there. Did I put VS Code there? That's not going to work. No, it's not recognizing it. That VS Code is in the wrong place. It goes there. And that's the problem. User data goes red. Why? Includes defines you're fine. Launch JSON. And that's /user data. That's okay. That's wrong. That would be user data as well. Yeah. Okay, that's right now. Is it? Yeah, that's right. Tasks. Ah, there's one missing. No, that's the wrong thing. Jesus, I wish it wouldn't do that to me. Tasks. Yeah, that was it. Save. That's not going to work. That will work. That is user data / build. Good. That'll work. That'll work. Red's gone. Things are now matching up. Everything should work. Okay. So if you stop opening everything up for me, close absolutely everything down. All I want is this. Alright, I'll put main inside my folder so it knows that that's what I want to build. Run build task. User data. What? Oh, no, 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 no. Hash include data window.h, yeah. Queue application, yeah. It's not picking up the VS Code there. It's not picking that up. That's crazy. I'm not playing with this anymore. So, off to you. Let's see, we are going to new folder. New folder is going to be data. And in data, we are going to place you and you. New folder. Model 3D. That's what we're interested in today. So stuff that one. We don't care about that one. Alrighty. How can we construct this? Okay, that's easy enough, isn't it? Qt. Qt will construct it for us. So new. Qt widgets application includes Qt designer based main window. Yes, choose. We want one of those. What we're going to call it? It's a converter, isn't it? Model 3D. Converter? Yes, converter. And it's going to go into Tools, Model 3D. Okay. User's default project location. Next. QMake. Next. Main window. No. That's going to be converter window. Yep, that's okay. Base class, yep. Generate form, yes. Looking good. Next. If you plan to provide translations for the project, no. Next. Desktop details. Doesn't matter. No. Next. Add version control. Git. Yes, please. Finish. and it's all added. Just check version control down at the bottom. We do have our lovely thing. And all it does in debug is that. There it goes. So that's what we just created. Converter window. Thank you. We now have to duplicate that within here. So let's see, that's debug. Yeah, okay, that's fine. Delete. All right. So where's the best place to get this from? Let's go from here. Put that in the converter. So that's build /8 cd build make blad. Okay. So this is converter. We now need to look at the main, don't we? No, I need to look at the pro. Don't like core GUI. Don't like. Yeah, that's okay actually. Yeah, okay. Looking good so far. I'm not overly happy with that. So let me keep that on screen by doing that. Core GUI widgets. Why do we need widgets? Not sure. I'll take you. We'll pop you in there. Ah, right, yeah, it's already there, so I understand now, yeah. So we can take that off there. Press V and add widgets here. Okay. Bring that down a line actually. Right, that's got proper C11 and C++ latest. Good, right, that's good news. Config. Don't need that extra config, do I? No, don't need this lot either. So you lot can go. That's looking cleaner. I don't want to deploy, but we'll leave it anyway. Do we? Or not? I'll leave it. It's not doing any harm. People can remove it. I can remove it. So I'll leave it in, but I'll just note it out. Yay! That's looking good. That's looking good. Main convert window, blah, blah, blah. Yeah, that's fine. That is a good converter.pro. Yeah, that's fine. Right, coffee. No idea if that file's gonna work. New folder, build. So at least it has one. How are we going to build it? So open main. Hash include blah, hash include blah. So it can't find. Right, let's just do the build first. Run build task. User data build tools. Continue without scanning the task output. Never scan the task output. Never scan the task output for shell tasks. Learn more about scanning the task output. What? How did it know to do that? Well, I know that's wrong, yeah. So you just did something from somewhere. Executing task in folders tool. Build sh. So it knows that I'm using that. Good. Okay. And that's going in here. Right. We've just added Linux, blah de blah de blah. We have added Amber 3 DSL by accident here, but we haven't added it yet to our loader. That's fine. 17, yeah, that's fine. We should really put our profiles on 17 then. Really. To match everything up. I've been lazy and I haven't cleaned this up. There you go. I've already done it on this one. Alright, that's that done. Profile's looking good. Right, let's have a look at this VS Code. That should now help main out a little bit. Well, yes, no. Okay. Thought I had done. So that means I think I've got this in the wrong place. Hmm. There's VS Code now, yeah. Okay. No. No. Okay. Just put it right at the base. Tools. I'm now getting the feeling that I'm going about this wrong. Why doesn't this follow your path? It only goes on your base path by the sounds of it. So RPG Dev opens into its... Aha. Amber opens into its... Aha. So tools is a complete waste of time. Fantastic, let me just check. What have I got saved? Net dev. Alright. Amberskies, QT. Tools. Data. Cut. Research. Paste. Thank you. Yep. That's okay. So got that stored. Right. Model 3D, we haven't even started it, have we? So close that. Right, remove that. So we're just left with these three. Move that up to there. No, I don't think he's going to let us. He's not going to agree to that in a hurry, is it? There's the files. Actually, an easy way of doing this is just saying stuff it. Tools, delete, start again, because I want to do it differently. Yeah. Okay. Tools, go away. You're wasting my time. There we go. Right. Okay. This isn't as easy as I thought it was going to be today. I know my brain's off planet, but this is ridiculous. Do apologise. QT, CCC. Yeah, okay. New. Application. We'll call it model. Model 3D underscore converter. There we go. And we're going to create it in desktop Amberskies QT. Yeah. Yeah, use the default location. Next. QMake, yeah. We'll call that converter window. That's all I wanted to change there. Next. Language, don't care. Don't care. Git, do care, finish. Magic. That should now have done it right. No, I want to keep it open a second, because I also want to add Amber 3D. So I may as well add it whilst I'm here. How do we do that? Click on the top. Add existing library. Add library. Okay, internal. No, external. Yes, next. Fantastic. Library type. Yes. Library file. Browse. It's in desktop. Oops. Amber 3D. Build. There it is. Include path is there. So delete from there. Where's the delete button gone? Oh, wrong keyboard I was looking at. So yeah, just delete that. So it's everything up to Amber 3D SL. That's good. Linux, Mac and Windows. Bleh. I'll just do Linux. Library, yep, next. Include, depend. Yeah. Finish. Thank you. So we should now have access properly. The pro's been changed. Yeah. Right, once I'm in here, I'm just going to change this pro over. Widgets. That's that done. So what else have we got here in the pros? We also have C11. So C11 and C++17, please. So that's you done. Don't really want the following lines. That's you done. And of course I haven't got it in this one. Don't save. It's in here. I just want these lines here. Copy that. Just put it after the config. There we go. That's lovely. I know you can't actually. Wait a minute. So you can see what I'm doing. That does help, doesn't it? We'll put that up to 220. Should be 230. Yeah, you can see 230, can't you? Debug release, that's what I just copied over. Source, main, forms, default rules for deployment. I'll just hash out again. Because I'm not overly worried about them. That's lovely. And I will take you, cut, and just paste you down here somewhere. There we go. In case I need it later. There are also some other bits that I want to add. Just in case they're needed. I'll put that marker in as well. That's my distribution files or dist files. That's for any resources I accidentally chuck in. Right. We now have a profile I can use. That's good. Close. We can now take the VS Code from here, copy, file, add, open, add folder to Workspace, that's it. There it is. Add. Here it is. Yeah, that just goes in here. Paste. that gives us what we need. New folder, build. I need the SH. Copy. Paste. Lovely. Starting to look okay. Properties. Fantastic. Can I just close this down a little touch? Okay, properties. Looking good. Launch JSON. Build RPG dev. Got a feeling that's going to change, but I don't know what to yet. Yes, I do. I know what that's going to change to. It's going to just change to whatever the title is, isn't it? Model 3D converter. Model 3D converter. That's what it will change to. If you're on Microsoft, it'll be .exe. Just copy that. Place that in there. Yes, we're getting somewhere now. I can feel it in my Gershwasser. If you're German, you know what I just said. Build is empty. Good. Tasks are saved. Terminal. Run build task. Wow, that worked. Build. There it is. There's the file. So there's our launcher. There you go, that was a lot easier, wasn't it? When you do it right, if you do the initial step correctly, everything just follows on. There you go. Our converter window, now up and running in Microsoft Visual Studio Code. And that's the simplest method I know how to do. All I've done is copied stuff across, really. We now have 44 changes. There's something wrong. There's a file missing. No, there isn't. It's there. Okay. 44 changes. Alrighty. Stage changes, yeah, okay. Oh, it's because I've deleted all that lot as well, isn't it? Message. Set up new tool to take a model. Yeah, we'll call it the same so it makes sense. Model 3D and convert it for our uh, 3D library to load. Okay, tick that please. Done. You've got it now, you can just download it. It's on GitHub. If you want to get all of those changes that I've just suffered doing, you can get it from GitHub. Let's have a look. Just nip over to my GitHub, which is on github.com/Amberskies. We'll go into the Amberskies Qt folder, change it to development, and please say you still have tools. Where's it gone? Refresh. That doesn't look good, does it? No output. It's not there yet. 1 second. Passwords are needed. Let's see if that works. GitHub. Refresh. Model 3D converter. Here we are. So we're now here. Set up new tool to take a Model 3D and convert it for our 3D library to load. Right. Oops. I might have another look at that. I wanted to make sure development. Yeah, we've got rid of tools now. But I will put a data tool in here after. I'll bring that data tool back over and place it back in here. That's working good. Lovely. That's my website where you can contact me if you wish to. It's at www.amberskies.org.uk. Lovely. Fantastic. Get out of that. Let's have a look then. Look, see. Model 3D convert, eh? Got it working. Nice. So, what do we want to do? We want to have a display, and we would like to have a loader and a saver. Right, let's start making notes. What we're going to need to do. I always put my notes at the beginning. That wasn't right then, was it? That was right. Okay. Give ourselves a few lines and close. Thank you. Yeah, that's working. Lovely. So this program has the following goals. Okay. 1. To load any 3D model and that will be what? Initially .obj, but to be expanded. Yeah, we'll do that. Let's have a look. What else can we have here? 2 dot. Let's see. To be able to check and warn if faces wind the wrong way. So I think I've spoken about this in previous videos, that each face has to go in a certain order, either clockwise or anti-clockwise, depending on how you set up your OpenGL. Now, because I haven't been setting up my OpenGL, because there's no real need to do it, it defaults to counterclockwise. So we better put that here. Defaults in OpenGL to counterclockwise. or CCW, which is the abbreviation which is used in OpenGL. You can change it. All you have to do is enable clockwise. And there's possibly there'll be a macro for it. I can't remember what it was now. It'll be face underscore counterclockwise or face underscore clockwise or something like that. Backface. You know, it's part of the backface culling system that stops it producing the back faces. What happens is you can set OpenGL not to draw the faces you can't see, but it has to know which face is front facing forwards, and that's going to be counterclockwise in our case. So all our faces have to be drawn counterclockwise so that OpenGL knows which is the front face, so it doesn't draw the back face. Okay. Lovely, that's that part. Let's see, what else do we need it to do? To be able to generate normals if none supplied. Yeah, we'll do that. It's also going to have to generate smoothed normals at user's request, because you don't always want smooth normals. Trust me, on a six-sided box, you would not use smooth normals. It will ruin the look of a box because there's too few sides. But if you've got like 6 million triangles making up a model, smoothing out your normals reduces the number of indices you need to actually produce that model, and saves. That's where that saving space comes from. So 5 dot on smoothed normals offer compression of indices. Yeah. So if you've got 6 million faces, you're going to have 6 million indices. If you smooth the normals and then run a compression through and redo your indices, you can lose an awful lot of needed data, duplicated data. But you can only do it on a smooth normal. And now I need to explain that. What's the difference between normals and smooth normals? I haven't talked about normals at all, have I? Oh, Jesus. I just realised I haven't. I think we should do that. Let's talk about normals. Ooh, a bit bright for me, but anyway. That's okay. What can we do on that keyboard? We'll put that over there. Muppet's not there today. Where's me little map thingy? Here it is. Right, normals. What are they? So you have a triangle like that, okay? And each one of these is a vertex, as we've discussed possibly in previous videos. But at 90 degrees to that, there, 90 degrees there. Oops, not 190. That's not a good idea. Let's put that back. So 90 degrees there. Where else it has to be 90 degrees to? No, those are two 90 degrees angles. So it's actually 90 degrees to the face. That becomes a face. And that's CCW, method for drawing in OpenGL. Okay. This is your normal. Why is that useful? Right, so let's pretend we've got a face. Okay, that's our face. Looked at from the side. Doesn't matter which way it's facing. That's irrelevant. Here, we have a value of a normal. Here we have a value of a normal, and there'll be a third value of a normal on this one as well. So these two have their own normals. Okay, so you've got your normals at all 3 points, and every point on that face, those normals will be true. So you can pick any one of these normals, and that face, it will be 90 degrees. So I'm just going to put it in the middle. Okay, doesn't matter where I draw it. I'm going to try and draw it nearly 90 degrees. So that is 90 degrees. Your face. Or to the face that's being drawn. Okay. Why is that useful? And the answer is for a lot of reasons. One, you can know which direction the face is facing, because that will have, God, this pen, that will have an X, comma, Y, comma, Z vector. i.e. a direction and magnitude. Or length, if you don't like the word magnitude. But the direction is very important. Let's, for instance, say we put a table lamp over here somewhere. Doesn't matter where. Let's just put a table lamp. And there. There we go. At random. So this here is going to be our table lamp. And that's going to give out light. Okay. I hope we're alright with this so far. We understand what a light is, obviously. And that is light emission. Probably spelt that wrong. Don't worry about it. Don't care. Right. There is a joint here. There is a 90-degree angle spot right there. And that spot is on every single pixel. Every single pixel on that line that we've drawn has a 90-degree normal, which is the same for every single pixel. Now that light is static. So if I was to cast a ray, let's see if I can get this at least sort of right here. So that's a ray. And it just happens to hit that pixel there. Alright? What's it going to do? It's not going to do anything because we haven't programmed it. What we can do is in our shaders, this is why they were originally called shaders, by the way, it has nothing to do with light, but light's included. So in our shaders, we can program that. So we can program in our shaders what happens. To the ray. And it depends where we're looking from. So now we need a camera. I'm going to put the camera, you could put it here if you want. No, that makes it awkward. Because the explanation doesn't really gel. It's still correct, but it doesn't gel. I'll put a camera here. And we are looking at that point, or that point our camera is looking in. Let's say it's looking, oh god, it doesn't matter which way. So we have a view, don't we? Let's say we're looking at that pixel. But that pixel, you'd know about reflection, obviously. Reflection means that that is the reflection there. So that's ray reflect. Now I've done that completely wrong. Well done. Reflect. Okay. What we need to know is what we need to know as a viewer on the screen. Move you a minute. How much of the ray do we see? And the reason I put a percentage mark there is because really you could measure it as brightness. Brightness. Come on, computer. So, what percentage of this light really is what I've said? How much light can we see from our camera? And we can work that out very, very, very simply by doing one thing. And we normalize the normal. We make that into a unit length of 1. And then we can calculate using sines and cosines, because we've then got a circle. We can use sines and cosines to calculate the percentage of that we see from here due to the roughness of that point. So we need a roughness variable. Face. Due to its roughness. So not everything will reflect the same amount of light, and not everything will reflect light in the same way. So it depends on your material. So we need a material. So now I think I've got all of the variables on screen at once, which is a hell of a mess and a hell of a lot to think about, and very, very complicated for the human brain. And as everybody knows on this channel, I am not a complicated person, so this is too much for me. All right? And my brain's off planet at the moment. I'm on high painkillers, and to be quite honest with you, thinking about something like this, no thank you. We're not going to think about things like that, are we? No. We're just going to realise that a normal means that we can use light, and we can use light on an object to see the object in the correct way, which we would expect to see a 3D object being lit. Okay, I think that's good, and I've got flashing screens going on. All right, so yeah, that's possibly the best explanation I can give in the shortest amount of time. I have talked about normals, and I've been through normals, so yes, I have. If you want to know more about all of this kind of thing, a good series to watch is my beginning series, actually. I would think I've talked about normals in there more than I have here. I may have also done it in the programming club. But if we go over to our playlist, we make sure that we're on created, and we look down at the bottom, stage 1, stage 2, stage 3, and stage 4. I may have talked about it in that set of videos. And again, I might not, I might glossed over it. But I've now talked about it, so if you want to ask questions about normals, please feel free. If you want me to do a special videos all about normals and lighting, then I will. Alright, so just let me know. You can contact me. I mean, I'm not hiding me mailing address or anything like that. And I am now very, very, very dry-throated. Oh no, it's one of those orange thingies. We had difficulties with this last time. Oh Jesus, how do these open? Oh, this is getting seriously bad. Oh Jesus. Alright, so we've got on smooth normals offer. Yeah, I didn't explain the smooth normal. Very simple idea. On a complex object, you're going to have lots and lots of normals. Let's put that there for a second. The top back on. Well, that was easier than the last time I opened one of those. That was good. Mind you, I knew what to expect this time. So a smooth normal is where you would take... Oh, I can carry on with this, can't I? Yeah, okay. Just move that up. Okay. Alright, I'll leave that bit on. Where's my mouse? Where's my pen? Thank you. So, smooth normals. Okay, put it back on pen then. Okay. There's a very easy explanation for this, but it's very complicated when you think about it. Again, we'll look at the faces on their sides. So we'll have face 1, pretend it's a straight line, face 2, face 3, face 4, face 5. And these faces are very, very small. So let's say that is the length of, say, 3 pixels. On your screen. To give you an idea, so I've just drawn dot, 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 dot. So it's that size. Very well, it's smaller than that even. Normals. We have a normal there. We'll just dot them in. We have a normal with it. We have a normal going up the screen. We have a normal going up the screen. We have a normal coming out of that face. We have a normal coming out of that face. We have a normal coming out of that face. Normal coming out of that face. One coming out of this face. One coming out of this face. This will give you jagged, especially there. That'll be a problem, that one. Because that is very, very a nasty curve. Yeah, that's a sharp angle. So where you get these sharp angles, you're actually going to get this scattering of the light, where you will actually have dead spots of light. If you're looking down, dead center of those two, you'll have a dead spot, and that will go dark when it shouldn't do. That should twinkle bright, especially if the sun's, say, here. That'll be a dead spot, because the sun will come down here and reflect that way, and the sun will go down that way and reflect that way. You've got a dead spot somewhere in there, and that will dim. It'll flicker as people go past it. Or you will create a situation where you've got cancellations of light in effect. So what do? We have smooth normals. So that normal this isn't attached to anything. So the smooth normal for that one is, we're going to say it's there. The smooth normal for this one goes directly between the two. There is the average of the two there. It's your smooth normal. Average of the two. Smooth normal. Average of the two. Smooth normal. Average of the two. Smooth normal. No more dead spots. And that's just a normal coming out. So as you can see, we lose data by smoothing it. And it also means we don't need to record as many indices, because for each one of these original normals, we needed an indice for a vertex with a normal. And an indice for the same vertex, but with a different normal. So we've actually halved. So now, instead of having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 indices, so I before E accepted. It still doesn't look right. Don't think you have the S. That looks better. Indices. We now go down to 1, 2, 3, 4, 5, 6. 40% less data. And that's just on a simple example. when you get a complex example, when you're looking at surface view, we'll draw the same ones, but we obviously won't be able to see in and out. So the first triangle, we'll put that direction. Second triangle, we will put in that direction. The next triangle we'll put in that direction. The next triangle we'll put in that direction. The last triangle we shall put down here. Okay, which has 1, 2, 3. Okay, so for each face, we have three vertices. 1, 2, 3, 4, 5. Right, so 5 vertices. So 5 faces. So 5 faces equals 5. Yeah, that's 3. 1, 2, 3, 4, 5, 15 verts. Which, if we index them, we take out the doubles. So we would only have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, yeah. Only 7 verts required. And you can work out the percentage of that yourself in savings of data. It's a lot. It's just simple idea, because you don't have to, that is duplicated, so that one actually isn't, that's tripled. So there's 1, 2, 3 faces on that one, so that's tripled. That one's doubled. That one's 1, 2, 3, 4 quadrupled. Single. But you can get the idea. That one, no it isn't. That's, no, they're all doubled. That's the only, that's single. That's single. So the only 2 pieces of data that we're not going to affect by smoothing are that one there and that one there. This one here, quadrupled, will save 75% of the information. On doubled, we'll save half, 50%, and on tripled, we'll save 66%. So the least we can save really is like 50%, and I'm talking like 40% less data, but that's what it actually works out to, by the way. That's the correct value. It works out on average to be about 40% less data, but obviously it could be higher depending on the model. So, something to think about, smoothing your normals. Try not to smooth your normals on hard-edged objects, like a box, because it will have an effect that is, not expected, because there's too few vertices and normals to work with. Like smoothed, can we get back to a pointer? No, we can't. The smoothed, that one there, the quadrupled one, when it isn't smooth, that's just going to facet. That's going to just produce facets all over the place, depending on which direction that is, down or up from the other ones. It's pretty awkward to work out. There we go. So that is the idea of smooth normals. It's a way of... No signal. Signal. Okay. I don't think the internet's working properly, folks. So I might shorten this down to just here for now. And review this footage. Make sure everything's going okay before I continue. Because if only half this video is going out, there's no point in continuing, obviously. So I'll go and do a review. I'll leave you with the thoughts on smoothing normals, but you've now got a good idea of what we are going to be proceeding to do. To load, to be able to check, to be able to generate, offer compression, in other words, remove unneeded indices. What else do we need to do? Let's just get back to the keyboard before my internet collapses. And if it does, that's the end of my world. It's the only contact I've got with the outside world right now is this internet connection. And it's not behaving itself. So it's my internet provider that's possibly under threat at the moment. So 6. Well, I'll put 6 here because that's our final. Save final data in a format for easy loading in the 3D library. In other words, just save the data out as what it is, what it actually is, rather than like the OBJ format, which is bleh. So it'll be text. We'll just save a bunch of text out, and that will be our model in our format, and we will decide I'll put it here. We get to decide what that format is, and it's not going to be anything complicated, obviously. So I think that's where we're up to. Oh, it's actually in there. That's okay then. I'm going to have to leave it here because I can't trust my internet connection, so I'm going to go and take a look at that. I'll come back possibly a bit later if I can. I'm not sure if I'm going to survive that long. My medication is already kicking in badly from yesterday, so I'm drifting. I'll try and get back to you. So in the meantime, take care. Focus, come on, focus. Take care, you people. I can't say have fun at the moment because I don't think anybody's having fun, and I'm certainly not. So take care. Hope everything's okay, and I wish you all the best in surviving.